Hello everyone. In this video, we are going to discuss about empirical formula for molecular formula. You see, empirical formula, it is the simplest formula of a compound. It actually represents the simplest all number ratio of various atoms present in a compound. And molecular formula, that is the actual formula of a compound. It shows the exact number of different types of atoms present in a molecule of a compound. So you see, empirical formula is the simplest formula and molecular formula is the actual formula. For example, if you consider the compound glucose, its chemical formula is C6H12O6. Okay, that is the actual formula of glucose. So that actual formula is actually the molecular formula. So the molecular formula of glucose is the actual formula C6H12O6. See, the subscripts of carbon, hydrogen and oxygen, that is 6, 12, 6. See, these numbers are actually multiples of 6, no? So if we divide their subscripts by 6, 6 by 6, 12 by 6, 6 by 6. So from this we will get C1, H2, 12 by 6 is 2, O1, or we can write it as CH2O. Okay, see, we simplified the molecular formula of glucose from C6H12O6 to CH2O. You see, this simplest formula, that is the empirical formula of glucose. Okay, so C6H12O6, that is the actual formula of glucose, which is the molecular formula of glucose. Now, when we divide their subscripts with 6, because you see, all these subscripts are multiples of 6. That's why we divide them with 6. Okay, suppose they are the multiples of 8. You can divide them with 8. Okay, so here the subscripts are multiples of 6. So we just divided it with 6 and we got it as CH2O. That is the simplest formula. That is, we simplified the formula from C6H12O6 to CH2O. So this simplified formula or the simplest formula, that is actually known as the empirical formula of glucose. If the mass percent of various elements present in a compound is known, its empirical formula can be determined. Molecular formula can further be obtained if the molar mass is known. Let us see one example. That is, we are going to discuss this problem number 1.2. It is related with this empirical formula and molecular formula. So you see, a compound contains 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. The molar mass of the compound is 98.96 gram. What are its empirical formula and molecular formula? That is the question. So let us solve this question stepwise. The first step is conversion of mass percent to grams. The first step is conversion of mass percent to grams. That is, let the compound contains 100 gram mass. Okay, then in 100 gram sample, we have 4.07% hydrogen. That means we have in 100 gram sample, we have 4.07 gram hydrogen. We have 24.27% carbon. That means we have 24.27 gram carbon. Okay, and 71.65% chlorine. That is, we have 71.65 gram chlorine. Okay, so the first step is conversion of mass percent to grams. You see in the question, the mass percent are given 4.07%, 24.27% like that. We just converted them into gram by considering the total amount of that compound as 100 gram. Okay. Now, step 2, convert into number of moles of each element. Okay, see we have converted the mass percent to grams. Now convert that into the number of moles of each element. You see, number of moles of an element in a compound is actually equal to the given mass of the that element, okay, divided by atomic mass of the element. The number of moles of an element in a compound is equal to the given mass of that element divided by the atomic mass of the element. So, the number of moles of hydrogen, you see the number of moles of hydrogen, that will be equal to the given mass of hydrogen, that is the mass obtained above, which is 4.07 gram. Okay, divided by atomic mass of hydrogen. Atomic mass of hydrogen is 1.008 gram. Okay, when you do this calculation, you will get it as 4.04. Okay, similarly, the number of moles of carbon, that will be equal to the given mass of carbon, that is 24.27 gram, divided by atomic mass of carbon, which is 12.01 gram. When you do this calculation, you will get it as 2.02. Okay, now the number of moles of chlorine, that is equal to the given mass of chlorine, that is the mass obtained above, which is 71.65 gram, divided by atomic mass of chlorine, which is 35.453 gram. When you do this calculation, you will get the answer as 2.02. Okay, so the second step is the conversion of that, first in the first step we converted the mass percent into grams. Then in the second step, we converted that into the number of moles. Okay. So in the second step, we got the number of moles of each element. Number of moles of hydrogen is 4.04. Number of moles of carbon is 2.02. Number of moles of chlorine is 2.02. Now the third step is divide each of the mole value obtained here by the smallest number amongst them. So here these are the mole values obtained here. We just want to divide these numbers by the smallest number among them. You see the smallest number is 2.02. No? So we want to divide each number of mole value with 2.02. So 4.04 divided by 2.02. When you do this, you will get 2. Okay, similarly 2.02 divided by 2.02, you will get 1. Again 2.02 divided by 2.02, you will get 1. Okay, we are actually getting the ratio. Okay, we are actually getting the ratio 2:1:1. This is actually for, you see, hydrogen, carbon, chlorine. So for hydrogen, carbon and chlorine, we are getting their ratio as 2:1:1. See, in case the ratios are not all numbers, then they may be converted into all number by multiplying by the suitable coefficient. Okay, here they are all numbers, so it is quite okay, 2:1:1. Alright. So in the step 3, we got the ratios of these elements present in the compound, that is 2:1:1, that is for hydrogen, carbon, chlorine, that order. Okay, now in the fourth step, we want to write down the empirical formula by mentioning the numbers after writing the simples of respective elements. So you see, in the compound we have carbon, hydrogen and chlorine. Okay, now you see their ratio 2:1:1. So for carbon 1, for hydrogen 2, for chlorine 1. That is CH2Cl. So you see the CH2Cl, this is actually the empirical formula of the compound. You see the empirical formula of the compound is CH2Cl. That is the simplest formula of the compound. Okay. Now in the step 5, we are going to write the molecular formula. For that, the first step is determine the empirical formula mass. Empirical formula is CH2Cl. Now how to determine the empirical formula mass? That is the empirical formula CH2Cl. We want to write the empirical formula mass. You see, to get the empirical formula mass, we want to add the atomic masses of various atoms present in the empirical formula. So in the empirical formula, we have 1 carbon. So its atomic mass can be written as 12.01 gram. Okay, plus there are 2 hydrogen atoms. So 2 into 1.008 gram, because mass of 1 hydrogen atom is 1.008. So 2 hydrogen, 2 into 1.008. Plus 1 chlorine, that is 35.453 gram. When you add all these, you will get it as 49.48 gram. So you see this 49.48 gram, this is actually the empirical formula mass. Okay. So we determined the empirical formula mass as 49.48 gram. Now we want to divide the molar mass by the empirical formula mass. See, empirical formula mass is 49.48 gram. Molar mass is given in the question as 98.96 gram. So we want to divide the molar mass with the empirical formula mass, which is 49.48 gram. So when we divide these two, we will get it as 2. That number is n. Okay, so molar mass divided by empirical formula mass, that is equal to 2, that is taken as n. Okay, now what we want to do is, see, the empirical formula is CH2Cl of this compound. Then to get the molecular formula, we want to multiply the empirical formula by n. Okay, we want to multiply the empirical formula by n, that is 2 here, to get the molecular formula. So C2, that is, you just want to multiply their subscripts. H2 2s are 4, then Cl2. Okay, see, this is like C1H2Cl2 now. So 1 into 2, 2, 2 into 2, 4, 2 into, this is 1 here. So 1 into 2, 2. Okay, so this is the empirical formula and this is a molecular formula of this compound. So in this video, we have discussed about the empirical formula for molecular formula. I hope it is clear to you. Thank you.